In this video, you will learn how to write and solve compound inequalities. A compound inequality is defined as an inequality joined by and, or. Now the top example is an example of an and inequality, and the bottom one is an example of an or inequality. One way of writing an and inequality is like we have at the top. It says x is greater than -3 and x is less than or equal to +1. So because it's and, we want to find the values for x that satisfy both of these. So if we were to graph these inequalities separately, I can go to -3 on the graph and draw an open circle and draw my line to the right. To graph the second part of the inequality, I'm going to go to +1, put a closed circle, and draw my arrow to the left. Now the intersection of these two inequalities is our solution. So we're talking about this circle and our other circle at +1 and the entire area in between. Now the way it's typically going to be written is like we have at the bottom. So in order to graph that, we would go to our original number. So we go to -3, we put an open circle because of the inequality symbol. Go to +1, put a closed circle for the inequality symbol, and shade in between. So whenever you're thinking of an and inequality, or something written like we have there, you want to think that you're shading in between. When we are graphing an or inequality, we're going to graph the two inequalities separately. So first we're going to say x is less than or equal to -2. So I'm going to put a closed circle at -2 and draw my arrow to the left. Or x is greater than 4. So I'm going to put my open circle at 4 and draw my arrow to the right. A way to help you remember this is to think of an or inequality as being oars on a boat, because they go in our opposite directions. Now here are a few examples of graphing compound inequalities. So for the first one, it's an or inequality, so we're going to think of it like oars on the boat. So we'll graph them separately. So I'm going to graph the first part of the inequality. So I'll put a closed circle at 0 and draw an arrow to the left. The other part, it says x is greater than 2. So I'm going to put an open circle at 2 and draw an arrow to the right. The next example we have is an and inequality, so we're going to think between. So we're going to graph our 2 points. So we go to -4 and we use an open circle. Then we're going to go to +4 and use a closed circle and draw our line to shade in between. The next example is another or inequality. So we're going to go to +5, put our closed circle and draw the arrow to the right. And then we're going to go to -6, put our closed circle and draw our arrow to the left. And the last example is another example of an and inequality. So I'm going to first plot my 2 points to graph between. So I'm going to go to -3 and use the closed circle. And then I'm going to go to +1 to use an open circle and shade the points in between. Now in order to solve an and inequality, you want to still isolate the variable. So we get it in that form like we had in the last slide. So we're still going to repeat the same steps we would just like we were solving an equation. However, whatever you do to one part of the inequality, you have to do to every single part. So for this example, if we want to get t by itself, I would have to subtract 4. Now since I'm subtracting 4 from the center, I'm going to subtract 4 from every part. So I'll get -9 minus 4 becomes -13. Carry my inequality symbol. This becomes just t, and carry the inequality, and then I get 10 minus 4 gives us 6. Now this gives us the inequality we're going to graph. So we're going to have an open circle at -13, an open circle at 6, and I'm shading in between. To solve an OR inequality, you're going to solve and graph the two inequalities separately. So for the first inequality, in order to solve, I would subtract 9 from both sides, which will give me negative 6x is less than negative 6. Then, to finish solving, I would divide both sides by negative 6, which would give me that x is greater than 1 because, again, remember that since we're dividing by a negative, you have to flip the inequality symbol. Now we're going to solve the other inequality. So to first isolate the variable, I'm going to add 8 to both sides. That'll give me negative 3x is greater than 21. And to finish solving, I divide both sides by negative 3. And that gives me x is less than negative 7. Because again, since I'm dividing by a negative, I have to flip the inequality symbol. Now the last part is I graph the two separately. So x is less than negative 7, so I'm going to put an open circle and write negative 7 and graph to the left, and x is greater than 1. So I use an open circle at 1 and graph to the right. Another example of an and inequality would be the one we have here. So we have to do the same thing to all three sides to isolate the variable. So if I want to undo that adding of 3, I'm going to subtract 3 from every part of this inequality. So that'll give me 1, I carry down the inequality symbol, x, carry down the inequality symbol again, and 9. Now I'm going to graph. So I'm going to go to positive 1 and use an open circle, go to positive 9 and use a closed circle, and then I'm going to shade the area in between. In our final example, we're working with an OR inequality again. So we're going to solve the two inequalities separately. So for the first one, I would divide both sides by 3 to get the variable by itself. It's going to become x is greater than 5. For the other inequality, I would divide both sides by negative 2. That'll give me that x is less than negative 2 because, again, in this case, since we're dividing by a negative, we have to flip our inequality. Now we're just going to graph our two inequalities separately. So x is greater than 5. We go to positive 5 with an open circle and shade to the right. And x is less than negative 2. Go to negative 2, use an open circle, and shade our graph to the left.